x plus 3 in brackets squared minus 6x plus 3 minus 16. So some of you might think, oh, I should multiply this all out and then recollect and go from there. There's actually an easier technique here. And what it is using the pattern. Does everybody see that there's a pattern of an x plus 3 in brackets? So what I do is I introduce a new variable and I say let a equal x plus 3. I always choose a. And then I rewrite it with an a in it. So instead of x plus 3 squared, I'm going to write a squared. Instead of minus 6 times x plus 3, I'm going to write minus 6a. And then minus 16. Now, would you agree now that this is a pretty easy one to factor? What would that be factored? What are factors of minus 16 that add up to minus 6? I heard 8 and negative 2. Think again. Negative 8 and positive 2. So a minus 8, a plus 2. Let's do a quick check to make sure we're right. A times a is a squared. Outer I get plus 2a. Inner I get minus 8a, which would give me minus 6a. And last I get minus 16. So that's not my final answer because my question never had an a in it. So now what we do is where we see an a, we put x plus 3 back in there. So we get x plus 3 subtract 8 times x plus 3 plus 2. Does everybody see what I did? I subbed the a back in. And so, where do I get there? What's x plus 3 subtract 8? X minus 5. And what do I get here? No, try again. X plus 5. And you might say, well, isn't it easier to multiply this out? Well, we could say, let's try that. What would we have to do here? You'd have to, oh, that's why we wouldn't multiply it out, because we might multiply it wrong. This is a FOIL. So we get x squared plus 6x plus 9. Then what do we get here? We get a minus 6x minus 18, yes? And then a minus 16. So these would cancel, and what are you left with? X squared. What happens when we get here? What's plus 9 minus 18? Minus 9. Minus 9 minus 16? Minus 25. What does that factor to be? Exactly what I got. So you might argue this might be faster, but you'll see in a second, these get pretty crazy in a sec, right? Okay, so again, if you introduce an A, you need to tell me what A stands for. You like the letter A, or do you want to use a different letter? A is fine. So what's A going to represent here? Yeah, so let A equal 3x minus 4. Then we're going to rewrite this with A's instead of 3x minus 4. So we get 6a squared minus 21a plus 15. Is everybody good? What's the first thing I should be doing? Yeah, see if there's a common factor I can take out, and there is. What is it? A 3. So 3 bracket 2a squared minus 7a plus 5. Don't forget the 3 when you factor again. So what is this going to be? Well, there's only 2 factors of 2, 2a and a, and there's only so many factors of 5. Play around with it now. What do you get? What would it have to be? It's 1 and 5. So do I put a 1 here or a 5 here? You put a 1 here and a 5 here, and in order for it to be plus with a minus sum, they both have to be minus. So let's just make sure that we did this right. 2a times a is 2a squared. Outer I get minus 10a. Inner I get minus 1a. Did that work? No. So that's why we always check. Let's try it again. So this should be a 5. Let's try it again. 2a times a is 2a squared. Outer I get minus 2a. Inner I get minus 5a. That gives me minus 7a. And last I get plus 5. Okay, next step, what do I do? Okay, now you got to watch. There's a 2a. So this is going to be 2 times 3x minus 4. Subtract 5. And then 3x minus 4. If you want, you can put these in brackets. Okay, so we still got to leave the 3 out. So what do we get when we multiply the 2 in? We get a 6x, and then 2 times minus 4 is minus 8, subtract 5 is minus 13. And then here we get 3x, and then I have a minus 4, subtract 1, minus 5. There's my final answer. Do you guys want to try the next one yourself, or do you want me to help you with that one? What is my a going to be? You know what? Alex is absolutely correct. There's going to be 2 letters this time. So let a equal x plus 2, and let's do b equals 2y minus 3. So then what do we get? 32a squared minus 18b squared. Is there a GCF I can take out of this? Huh? Well, it's even. So does a 2 come out? Can you get a 4? No, so only a 2 can come out. What am I left with? 16a squared minus 9b squared. Does anybody recognize that? It's the difference of 2 perfect squares. That's an easy factor, right? What does it factor to be? What's the square root of 16a squared? 4a, so 4a goes in the first one. What's the square root of 9b squared? 3b. One's a plus, one's a minus. You remember doing those factors? Am I done? No, I got to put the a and the b back in. So 4 times x plus 2 plus 3 times 2y minus 3. 4 times x plus 2 plus, sorry, it's a minus this time, minus 3 times 2y minus 3. Okay, so now I need to simplify this. We may have to do this in more than one step. So 2 bracket, what's 4 times x? 4x. What's 4 times 2? Plus 8. 3 times 2y. Plus 6y. 3 times minus 3. Minus 9. So I'm going to have to simplify this in the next step because those two are like terms, right? Okay, 4 times x. 4x. 4 times 2. Plus 8. Minus 3 times 2y. Minus 6y. Minus 3 times minus 3. Plus 9. Again, we need to simplify that. So what's my final answer? 2 bracket 4x plus 6y minus 1 times 4x minus 6y plus 17. Now, would you agree there's no way you could have factored that the other way? It would have been pretty difficult. Yes? Okay, so now we're going to start factoring with rational coefficients. So we might have fractions, we might have decimals. Anyways, what we're going to do here is we're going to remove a common factor to make it easier to actually factor. So, does everybody see here, there's a decimal spot in 2 of the 3 spots. So if we actually make this, instead of trying to factor decimals, we can actually make this into whole numbers by multiplying by 10. Well, you can't just multiply by 10. What's the same thing that you could do to compensate multiplying by 10? Divide by 10. So if you multiply by 10 and divide by 10 in the same expression, you actually haven't done anything. But it will make it a lot easier. Now, does everybody see if I divide by 10, that's the same thing as timesing by 1/10? Yes? Or you could say that dividing by 10 is like timesing by point 1. Okay, so if I divide by 1/10, that's the same thing as multiplying by 10. Okay, so I'm going to remove 0.1 out. And in order to compensate this, I can't just do that. I just divided by 0.1. So what's the same thing as dividing by 0.1? Multiplying by 10. So this becomes 10x squared plus 14x minus 12. Okay, so now watch this. At any point in time, if you don't know what you're doing, you should always check to see if you've altered the question so that it's different. But does everybody see if I multiply 0.1 times 10, I'll get 1x squared. 0.1 times 14, 1.4x, yes? 0.1 times minus 12, I didn't change it at all. I just made it look nicer. Now there is a GCF I can take out of this. A 2. So if I take a 2 out, what does this 0.1 become? 0.2. So that would be 5x squared plus 7x minus 6. If you want, I can show it in 2 steps just so that you realize this. 0.1 times 2 times 5x squared plus 7x minus 12. Do you see? All I did there is I multiplied 0.1 times 2 when I took the 2 out. So that's 0.2 times 5x squared plus 7x minus 12. Again, at any point in time, multiply this out and see if you get the original. So 0.2, I don't know what I did there, so sorry about that. That was an oopsie. Okay, so that's why you check, because you would have realized you made a mistake. So 0.2 times 5 is 1. 0.2 times 7 is 1.4. See? 0.2 times minus 6, 1.2. So at any point in time, you should be able to get back to the original, right? So hopefully we can now factor this beautifully. Well, there's only so many factors of 5 and 1, so 5x and x. Now play around with factors of 6 so you can get that middle term of 7. Now this is minus 6. That means one of them has to be negative, right? And in order for you to get a positive 7 sum, the smaller one has to be negative, right? So I'll give you a moment to play around with that. You should have had a 3 and a 2. This would give you a 10, and a minus 3 gives you the positive 7. So did everybody get that? You're going to get a quiz on this tomorrow, something like that, or a pattern. Okay, moving on. Sometimes there's a fraction in there. That would be pretty difficult to factor. However, I can remove the fraction by taking, if I take out the half, does everybody see? I just want to take out the 2 at the bottom. So if I take out the half, I'm actually dividing by a half. So what's the same thing as dividing by a half? Multiplying by 2 to compensate. So I'm going to pull out a half, and what am I left with? I have to multiply this by 2. So 2x squared. You see, if I multiply 1/2 times 2x squared, I get 1x squared, just like I had. If I pull that half here, what do I get? A 7x. And if I pull out a half here, again, multiply by 2, I get a 6. So let's just see if I have changed anything. 1/2 times 2x squared, 1x squared. 1/2 times 7x, 7 over 2x. 1/2 times 6, 3. Does everybody see what I did there? Okay. I pulled out the half and then multiplied each and every term by 2 as a result. And the 7 over 2 times 2 cancels that, right? And that's how I get the 7x. Okay, let's factor it. I'll give you a second to factor. Again, there's only so many factors of 2x squared, so 2x and x. Okay, so I got to get a 6. So I'm thinking, what am I thinking? 3 and 2 does not work. 3 and 2 works. Plus, plus. Is that what you got? Okay, so let's try the next two on our own. Look back if you can and try them out. Okay, so I take it a 0.1. So then I get 10x squared minus 15x plus 5. Then I take out a 5. So then that's 2x squared minus 3x plus 1. And then 2x minus 1, x minus 1. Did you get that? Okay. I'm taking out a 1/3, so I'm multiplying by 3x squared minus 17x minus 6. There's no common factors to take out of this. 17 is prime. So 3x and x. And then you got to play around with factors of 6. So I'm thinking it's 6 and 1, right? So then that would be, I'd have to get a minus 18 plus 1x to get that. Is that what you got? All right. Are we done? We are done.